Hey everybody, in this video we're going to continue talking about quadratic functions and their properties. And so in the last video we had actually done quite a few of these objectives and graphed our functions. Now this time we're going to find a quadratic function if we're given the vertex and one other point on the graph. And then also we're going to find the maximum and minimum values of that function. Okay, so let's find a quadratic function. If we know the vertex, hk, and at least one other point on the graph, then we can find the function. Okay, so remember this, we learned this last time. This is our vertex form of our function. And this same function is right here in standard or general form. And so, quick reminder, if you would like to go from this standard general form to vertex form, you have to complete the square. But we can just jump right into the vertex form if we know the vertex hk and one other point. Okay, so let's try out an example. Determine the function whose vertex is -3, -7, and whose y-intercept is 2. So notice the vertex gives us h and k right away, and we're going to be able to put those right into our quadratic function. So exactly where there's an h and a k, plug in our numbers, and then just be careful, you are subtracting h, so you're subtracting -3, so when you simplify, it's going to look like a +3. So far, we know f of x equals a times x plus 3 squared minus 7, and so notice we're almost done. The only thing left to find after you plug in the vertex is this number a, and so that is why you need another point. And for us, the other point is given as the y-intercept. And so you're going to use the y-intercept to find the value of a. And so notice, we're told it's the y-intercept, but we know at this point, anytime we're finding a y-intercept, it's because x is 0. So the point is actually 0, 2. And so we're using the additional point, so use the given point, the one given other than the vertex, and this is going to be to solve for a, that coefficient. Alright, so we know the output, the y value, is 2 when the input or the x value is 0. So plug in a 0 for x and a 2 for y, or f of x, and then just solve this equation for a. If we started right here at this equation and I said, hey, go ahead and solve this for a, you would be able to. It was just a matter of knowing that you needed to plug in x and y. Okay, so if you simplify this, this becomes 3 squared, that's where the 9 came from. Add 7 to both sides, and then just divide by 9. And you'll see very quickly that a is 1. Okay, and so that is the last thing we needed to write our function. And so you can put the invisible 1 here if you'd like, but because it's invisible, when it's 1, you don't really have to write it. So this is the answer, or you can expand it out. So this is the final version of the answer, and just so you know how you get this version, is just by foiling this out. So you would say x plus 3 times itself, and you would do the FOIL or box method for multiplying, and then you would subtract 7 from that. And I'll just show you really quick as a reminder. So x times x is x squared, and then x times positive 3 is 3x, and then 3x here as well, and then 3 times 3 is 9. Okay, and then that minus 7 right there is that's why we have a 2. So that's where the plus 2 came from. Alright, so here is the graph of our function. So notice we can graph it pretty quickly before we write it in this final version, because we knew two important things. We knew the vertex, which is really important, and then one other point on the curve. It just happened to be the y-intercept. And so if we plot that, we can use the axis of symmetry to plot the other point that's mirrored across this axis. So that one would mirror across to right here. And then you just draw your parabola through the curve, or through those points to make the curve. Alright, let's try this last objective. We are going to now find our maximum and minimum values of our function. And remember that on a parabola, the maximum or the minimum is the vertex, depending on if your parabola opens up or down. So if it opens upward, or let's start with down actually. If it opens downward, you have a maximum. If it opens upward, you have a minimum or a lowest point. And so let's determine the maximum or minimum for this one. And so notice for this function, your coefficients are a is 1, b is -6, c is -3. And then recall from last time, if the leading coefficient is positive, the graph is going to open upward. It's going to be concave up. So that's going to give us a minimum point. So because it's a positive x squared, this is invisible 1 here, it's going to open upward. And so we have a lowest point. And so the minimum occurs at the vertex. Okay, so you just need to find the vertex. And so from last time, here's our formula for the x coordinate of the vertex. So -b over 2a, plug in -6 for b and 1 for a, and then simplify, and that's 3. And so the minimum occurs when x is 3, but the minimum value, okay, so the minimum value is actually the y value. Okay, it happens when x is 3, this is x, but the actual minimum value, we want y. So we want f of that number. So just remembering how that part goes from last time. Let me just write down really quick what our function was. Let's go back and call that x. That was f of x equals x squared minus 6x minus 3. And so the y value is just what you get by plugging in that x number. So plug in 3. So 3 squared minus 6 times 3 minus 3, which gives us -12. So -12 is the lowest y value, or lowest function value, for our whole function. Okay, so for this one, for this concept of finding the maximum or minimum, you just want to find the vertex, and then the maximum or minimum, depending on if it opens up or down, is the y value. You have to find the x value first in order to plug it in and get the y value, but the maximum or min is the actual output, or the y value. Alright, one last example. This one is going to be more of an application type problem. So analyzing the motion of something that's being projected or launched. So a water balloon is launched from a stadium 100 feet above the ground. I'm going to just underline some important numbers. 100 feet above the ground at an inclination or angle of 45 degrees to the horizontal, with an initial velocity of 100 feet per second. Okay? Now from physics, the height of the projectile above the ground can be modeled with this equation here. So we were given a lot of initial values, but we can just go ahead and use this given function. And so why this is coming up in this section on quadratic functions, if you think about something being launched, it's going to go up and then come down. So if you can picture this, like you throw a water balloon into the air, it goes up and then it comes down. Okay, and so this is actually a parabola shape. So that's why things like this, projectile motion, are part of the quadratic function discussion. Okay, now x represents the horizontal distance. So x is how far this water balloon travels horizontally. If we want to put a x-axis here, it would be the horizontal distance. And then the y value is our function h, so the height. And that's the horizontal distance from the base of the stadium. And then part A, find the maximum height. And then B, how far from the base of the stadium will the water balloon hit the ground? Okay, so think about what these questions are asking, and then we'll solve them. So finding the maximum height, if this is a parabola shape that this water balloon traveled in, the maximum height is going to be from the vertex. So for part A, we have to find the vertex, and then we want the y value. Y value, because that is the height. So y value equals the height. And then B, how far? That's another way to ask what is the distance. And we were told x is the distance, the horizontal distance. Okay, so how far from the base of the stadium will the water balloon hit the ground? So we're going to get into this when we solve it, but just real quick, we have to think about what do we know about this situation. And what we know in terms of the height, because notice our function is height, we know when something is on the ground, the height is 0. And that's important because we need that to be able to solve part B. Okay? Alright, so here is a picture of this function. This is actually the graph of it. So this is the launch point at 0, 100, the stadium being 100 feet above the ground. So just sort of think of it as like you're in at a baseball stadium maybe, and you're in the stands and you're high 100 feet up. And then you launch the water balloon. It has a maximum point right here, maximum height, and then it starts to fall after that, and then it falls and it drops onto the ground. Right, so this is a visual for what's happening. Now the height of the water balloon was given by our quadratic function, and so what we want to do is we want to find the vertex because we are asked about the maximum height. Okay, so the only difference here is just simplifying the fact that 100 squared is 10,000, and we want the maximum value of the height h, and so that's going to be at the vertex. And so using our formula, the x coordinate of our vertex, we're going to plug in b. So I want to just highlight it for you here. So this whole thing, if you think of this as ax squared plus bx plus c, this whole quantity here is a. Right here, invisible 1 is b, and then 100 is c. Okay, and so notice this is negative b over 2a. That whole quantity is a. And then just simplify that, and then you get 156.25. And you can use a calculator for that one just to simplify. Okay, so that's our x value. And then the y value is what we want. So this is our y value. This is the height. So this is y, and this is the height we're looking for. Let me just put what this equals from what we knew before. This is exactly f of negative b over 2a. This is exactly our vertex formula for y, the y coordinate. Okay, so we found the x value. We plug it into our function to get the y value. So this used to be x, we plugged it in here and plugged it in here. And then just go ahead and simplify that, and you'll get 178.125 feet. So the maximum height that the balloon reaches is about 178 feet. And then part B, the water balloon hits the ground, like we said, when the height is 0. And then x was our distance, so notice we have to set the height equal to 0. And then we have to solve this quadratic equation for x. Okay, and so we did this in the last video, but you have some options. Solve a quadratic equation for x. You can factor, you can use, so let me write down what we've done in the past. You can try to factor, you can complete the square if you want, you can use the quadratic formula, and that is going to be the easiest one, honestly, especially in this example. So these are your three options, and we are going to use the quadratic formula to solve for x. So remember this part here from last time? This is the discriminant of your quadratic formula. It lets you know how many x-intercepts you're going to have. So just plug in B, A, and C. Because you got a positive number, you're going to get 2 x-intercepts. Now let's see what happens, because we saw the picture of the graph already. So reminder, here's your quadratic formula. Plug in your values for A, B, and C. We already did the work for this part, B squared minus 4AC. We did that on the previous slide. That's the 2.28. And then we have these two values. Okay, so think about the first one. We're actually going to get rid of that answer because this is negative. And if you think about the picture of our graph, it looked like this. And so that negative value would actually be back here. And that doesn't make sense for the context of our problem. That would be before we launched the balloon. So it doesn't make sense in this particular example, that number, even though we mathematically got that one to be correct. And so the water balloon strikes the ground at about 392 feet. So we solved for x using that function. So let's just kind of sum up this idea of this projectile motion and our quadratic function and how it works. So we have our function, and the maximum or minimum value is going to be your y value. It's going to be the y value of your function at the vertex. So y value at the vertex point. And then if we want to know something about the projectile hitting the ground, well, then we know that the function, if it equals the height, it's going to then be equal to 0. And then you solve, and most of the time you're going to solve by using the quadratic formula. You don't have to, especially if you can factor. If you can factor, then do that. But the one we just did was pretty hard to factor, so just use the quadratic formula, and then you'll solve for x. All right, so that is it for this one. Thank you for watching.